Okay, so today we're going to be talking about linear equations. And the way that you usually see linear equations is written in this form, y equals mx plus b. The important thing to remember here is that m stands for the slope, which is also known as the average rate of change. It's the way you might have heard of it in your algebra class. And b is the y-intercept. And the y-intercept has a lot of important properties. Usually, you can think of it like a starting value. It's also the y value when x equals 0, because on the y-axis, which is what this means, x is 0. So here in this problem, we have Sandra and Dan saving up for college, and they both work at grocery stores. Sandra starts with $4,000 already, and she earns $12 an hour working at the grocery store. Now, Dan, he only has $3,000 to start, but he makes $17 an hour working at a grocery store. Now, one question, why would $17 an hour for the man and $12 an hour for the woman? That's quite a question. I bet it's about roughly 72% of what the man makes. We won't get into that right now, though. So, with this question, we're looking at if y is the total amount of money and x is the number of hours worked, we need two functions. We need a Sandra function and a Dan function. So, the Sandra function we'll put in red, because I highlighted everything in red up there. Now, with this, it's going to be a y equals something x plus something. So y equals mx plus b. Now, well, we just said that the y-intercept is like the starting value. So it's like what you want to start with. What she starts with is $4,000. Now, depending on how many hours she works, she'll get $12 for each one of those. So that right there is basically our slope. It's like the average rate of change. For each hour, she makes $12 more. So 12x plus 4,000. Now we can do the similar thing with Dan here too. Dan's going to also be y equals something x plus something. Now Dan only starts with 3,000, so his y-intercept is 3,000. And because he makes more as a man, as we do in America, then he gets $17 for each hour. So the question we want to answer now is, when do they have the same money? And remember, y tells us the money. So we want to know, when are these the same thing? Or in other words, when are these equal to each other? So we just write 12x plus 4,000 equals 17x plus 3,000. So this equation here has x terms on both sides of the equal sign. So like this 12x on the left and the 17x on the right. The best thing to do right off the bat is to get the x's to one side. So I'm going to move this 12x from the left to the right. And you do it by using the inverse. Since it's a positive 12x, I'm going to subtract 12x from both sides. Those will cancel out to 0x. We're left with just 4,000 on the right, on the left. And then on the right, we have 17x minus 12x is 5x plus 3,000. And now, this is a simple two-step linear equation where you just need inverse operations to solve. So you do the opposite. You subtract 3,000 from both sides. And that cancels out on the right. You're left with 1,000 equals 5x. Since 5 times x, we do the inverse and divide. And what we learn is that x equals 200. So what this means is that after 200, and remember, x is the number of hours they work. So after 200 hours of work, Dan and Sandra have the same money.